I was really excited to take this class, Cloud Computing for Biology and Healthcare, because there's just unlimited applications with the new technologies arising that can really advance healthcare and improve the lives of many people, and cloud computing is a big part of that.
This is one of the few classes that gives you practical hands-on knowledge with using cloud computing tools such as AWS, Google Cloud, and Azure. And I think that's exceptionally useful, not only in this area, but if you want to go into industry.
It's really important for physicians and scientists of the future to have a good understanding of how to leverage cloud computing to extract meaningful insights.
We have so much data in healthcare, and having to process that and having to get useful insights from all of that data requires a lot of processing. And you really can't do that without the cloud.
How to take these massive data sets and sort of work with them, how to sort of break it down, use pipelines, troubleshoot any issues you come up with, and sort of really, go from this really scary looking data set to be able to sort of ask and answer a few really simple but intriguing, I think, questions.
I think cloud computing is very revolutionary for healthcare, for how we treat diseases, how we find drugs, how we coordinate hospitals, and it's very exciting. It's very exciting to be at the intersection.
Big data is becoming a lot more prominent in research right now, especially with the cost of sequencing a genome becoming more and more affordable every year. So I think we need ways to better utilize this data in a secure yet efficient manner. I think this is definitely something that cloud computing is well positioned to do. And this will ultimately lead to more breakthroughs and discoveries, which will go a long way to helping patients all around the world.
Scalability is definitely an important thing to learn about, because before you set out to build an infrastructure to process your data, you want to know that it's going to be able to help more than just a handful of patients in a feasible manner.
In terms of scalability, I learned that it is very important to test scalability in general, because it actually allows you to make very important design choices when you choose your virtual machine and how you build your pipeline.
When there's one patient, it's super easy to analyze their data, but for us to enact true positive change, we need to be able to do this at very large scale. And so using cloud computing technologies to not just analyze one patient, but analyze thousands and thousands of patients at once.
But it's definitely really important, especially when you're working with cloud tools, to be able to develop things that are scalable so that you can provide these services and tools for multiple people, huge amounts of people, because you're working with a lot of data. So it's important that your system can be able to support doing all the computation in an efficient way.
You start going into processing times that are days and years long. And so having to think about scalability is really important so that you can get the information that you want in a reasonable amount of time.
And so getting to learn more about how to ensure that pipelines and such are scalable was very valuable information. We also spent a lot of time talking about security, learning about HIPAA and different regulations like that. And I think that's also so important. The patients entrust those in medicine so much with their data, and it's very sensitive. And so being aware of all the different ways that data needs to be respected and treated with privacy, and how to do that on a practical level.
Everybody knows security and privacy is really important, but learning how to implement it and learning what your responsibility is versus what the cloud provider's responsibility is. This class really put a microscope to that and helped me understand going forward in my solutions how to make a system HIPAA compliant.
I think the average person is already a bit hesitant in using this technology because of security concerns. But what I took away from this course is that these infrastructures are actually much more secure than what we have already in the hospitals.
We learned in the course that when you're using cloud computing, there's sort of teams of experts from, Google, Amazon, Microsoft, depending on the cloud you're using, they're really able to manage the data well. So it's not, a couple people trying to manage, their own cluster. There's sort of these large security teams. I think that cloud computing, it was a really great course because it sort of brought all these different disciplines together and everyone sort of walked away with something.
Yeah, having this in our arsenal will really enable and empower computer scientists and doctors to really work together and collaborate in a way that we haven't seen before, that will lead to bettering the lives of patients.
it's really difficult for one person to know all of the medicine, also be a great programmer, and also have experience at the bench, doing bench research. Of course, you can get familiar with those different aspects, but I think for any good progress to be made in these sort of interdisciplinary pursuits, you do need an interdisciplinary team.
Interdisciplinary work can be quite challenging because, you have people that are coming from very different backgrounds, and they need to become familiar with like terms and terminologies, concepts, ways of thinking that they may not have ever encountered before. And I think this class really develops that skill of being able to talk with, interact, and learn from people that come from very different backgrounds.
Biologists, for example, they understand the science and they spend a lot of time in the lab creating awesome technologies, and computer scientists have no experience in that whatsoever, but they're really good at implementing algorithms, and kind of combining these two aspects can really scale up biomedical solutions and provide computer scientists with interesting new applications.
I always think about like how there's lots of great talent in the biggest companies like Google and like Facebook, and how like right now they're working on making more people click on ads. And so the reason why I think like more computer scientists should get into biology or the natural sciences is just the kind of impact that talent and knowledge can have on these different sciences such as biology.
I think that's one reason why I chose to study computer science on the biocomputation track, because there's really just so much that you can accomplish when you're combining engineering and biology, especially in healthcare. There are just like endless problems that need to be solved.
One of the beauties of computer science is its ability to be applied in many different fields. So even if you're not interested necessarily in biology specifically, you learn so many skills in this class.
There's a lot to learn here, right? A lot on the biology side and a lot on the cloud computing side.
I'm excited to kind of take what I learned and carry it with me forward in the rest of my career building healthcare solutions.
It's a really good experience that I'll definitely take with me, and the lessons learned from this class, I'll try to apply them to my current research as well as any future projects I work on.
I don't think it says this in the course title in their description, but it really gives you a powerful look at what sort of modern biology is and how so much of it is done.
Everyone is really happy to help you and teach you more about what's out there and what's possible in the intersection of biology and computer science.